What's up guys, welcome back. In this video, we're gonna go over a range of different optimization problems. We'll do some which are kind of a little bit more straightforward and then kind of more obscure ones and more difficult ones. So with that said, let's get into it. Okay, so this first question says, seeing the recent success of Prime Hydration, you decide to launch your own beverage product. To compete with Prime, the volume is to remain the same as the product, 500 milliliters. However, your drink will be packaged in an aluminium cylindrical can. To minimize the production cost, you are required to minimize the materials and hence find the dimensions required to do so. So question I says, show that the height is 500 over pi r squared. Now, this is a rule of thumb whenever you're doing maths problems, if you can draw a diagram, draw a diagram, because it just helps visualize what's going on. So I know that our drink has to be some sort of cylinder, like so, and our volume is 500 milliliters, as it says in the question. Our radius here is r, and this must be our height. So I know that the volume of a cylinder is given by pi r squared h, and our volume is 500. So 500 is equal to pi r squared h. So I'll make h the subject. So 500 over pi r squared. Right, easy. Okay, so II says, hence find the radius and height of the cylinder required to minimize the cost. So what we need to use is, we've got to use the fact that there's some sort of surface area, right? Because we're trying to minimize the surface area. Well, what's the surface area of a cylinder? 2 pi r squared for the circles, plus 2 pi r h for the bit around, like what you hold on to. Whenever you do these optimization questions, it kind of leads you in. So you're going to need to use this value, h is equal to 500 over pi r squared. So what I'm going to do is I'm going to substitute that in. That way we can kind of get all the variables in terms of r. So 2 pi r squared plus 2 pi r 500 over pi r squared. All right, simplify this down. So you get 2 pi r squared plus this r and that r will cancel. This pi and that pi will cancel. So 2 times 500 is 1,000 over r. Okay, so now we can differentiate. So dA over dr. So we're differentiating with respect to r, so we've got to bring 2 down. So 2 times 2 is 4 pi r plus. Okay, now this situation here, right? That is going to be 100, just writing in index form. 1,000 r to the minus 1. So I bring the minus 1 down. That's going to cause this to change to a negative. So 1,000 r minus 2. So I'm just going to write that as 1,000 over r squared. Right? Now I need to solve for when dA over dr equals 0. So let me just cut up more space here. Okay, so when dr equals 0, we're solving for what we just found, 4 pi r over 1,000 over r squared equals 0. Now at this point we can times everything through by r squared, so 4 pi r cubed minus 1,000 is equal to 0. Move the 4 to the other side, so 4 pi r cubed is equal to 1,000. R cubed is equal to 1,000 over 4 pi. So R cubed, so it should be 4.301. Now, that's your radius, but you have to show that it's a minimum. So how do you do that? You actually have to differentiate twice to make sure this value is going to give you a minimum. So coming back over here for a second, if we differentiate twice, d squared a dr squared with respect to r is going to be 4 pi minus, now once again, this is going to be 1,000 r to the negative 2, so differentiate, that's going to make this a plus. 1,000 times 2 is 2,000 over r squared. And now you'll notice, no matter what value here I put in for r, this whole thing is always going to be greater than 0, okay? Because one, it's squared, so anything squared, even if it's a negative, it's going to be a positive number. So if that's positive plus a positive, I know that the second derivative is always going to be greater than 0. So therefore, we are going to have a minimum, because remember, greater than 0 means concave up. So therefore, r is equal to 4.031 is your min. To find your height, you just go back to your original h is equal to 500 over pi r squared. Put in my number in here. So sorry, 500 over pi of 4.301 squared. And you should get 8.603. Done. All right, let's look at this next one here. So an open top fish tank with a volume of 30 cubic meters is to be made in the shape of a rectangular prism. Draw a diagram again. With a length 3x meters, a width x, and a height h. The materials cost $20 per square meter for the base and $35 per square meter for the sides. So question A says, show that the total cost of the fish tank is given by that equation. All right, now once again, you need to, or you don't need to, but I would definitely advise you to always draw a diagram because it just makes it easier to imagine. So what do we got? We've got 3x here, we've got x here, and we've got h here, and it's an open top. So the base is going to be 3x squared, right? And all the sides, so think we've got this side, front and back, which is going to be 3x times h. We've got two of them. So the sides are going to be 2 outside of 3xh for the front and back. And then plus the left and right, you're going to have 2xh. So what does that simplify to? 6xh plus 2xh. So that's 8xh there. So therefore the total area will actually, hold on, before we actually figure out the total area, we've got to incorporate the cost. So it's $20 per square meter for the base, so I should times this by 20. That gives me 60x squared for the cost here. And then likewise times this by 35 should be 280xh. Okay, so therefore my total cost is going to be 60x squared plus 280xh. Now, we got this far, but that's not what they want. So we got the first part, 60x squared, but here they've got 2800 over x. So what do you do? Now I noticed looking at this formula here, there's no h, and we have an h. So it tells me we need to get h as a subject somewhere and then sub it out. Okay, so how do we get h as a subject somewhere? Well, I haven't really made use of this, right? The volume. The volume is 30 cubic centimeters. So what can I say? I can say the volume is equal to 30 meters cubed. And the volume of this box, or this rectangular prism, is base, so 3x times the width times the height. So that is 3x squared h is equal to 30. So h must be 30 over 3x squared. So that's 10 over x squared simplified. So I will probably need to use this fact. Let's sub that in and try. So cost is 60 x squared plus 280 x over 10, what did we say? I've forgotten already. 10 over x squared. Simplify that, 60 x squared plus, okay, this x and that x cancels out. 280 times 10 is 2,800 over x, and we are done for the first part. So part B says, find the dimensions of the tank with the least cost. Give your answer correct to 3 decimal places. So least cost is obviously we're going to minimize instead of maximize. So what we got to do is we need to find dc, dx, we've got to differentiate, find the value where the stationary point equals 0, and then also show that it, like prove it's a max. Either using the second derivative like the previous question or a table, but we'll get into that. All right, so differentiating here, you're going to get 120x plus, now think about this again, 2,800 over x is 2,800x to the power of minus 1. You bring that minus 1 down, that's going to cause this to go negative, so 2,800 over x squared. And we just solve for this, equals 0. So 120x minus 2,800 over x squared equals 0. It's times through by x squared, so 120x cubed minus 2,800 is equal to 0. Well, we could just let's move the 2,800 over. 2,800 divided by 120 is 70 over 3. And I need to cube root it, right, to get rid of that. So x is equal to, I'm going old school calculator here, it's just easier. So this is 2.8575. So that's one of the dimensions. But what we got to do, right, we got to show that it's going to be a minimum. So what we need to do is solve for the second derivative. Okay, so we need to differentiate this again, dc over dx. So dx over d squared c over dx squared will be 120 minus, so think about this, this will be 2,800x to the minus 2. Differentiate that, bring the power down. So 2 negatives, that's going to make that a plus. 2 times 2,800 is 5,600 over x cubed. And then once again, look here. No matter what value I put in for x here, well actually not no matter what, but if I put in this value here, 2.8575 into here, that's always going to give me a greater than 0. So I can say d squared squared c over dx squared 2.8575 is going to be greater than 0, so therefore it's going to be a min. All right, and so I think we just got to find all the other dimensions. What do we have? We got x up here, 3x, and then h, which is 10 over x squared. So, you know, just quickly working that out, I'm going to times this one by 3, which is 8.572. And then I'm also going to have a 10 over x squared. So that's going to be, what's that going to be? 10 over 2.8575 squared. So it's going to be 1.224. So there your 3 dimensions. Right, so here's the next one. A little bit more obscure, but the maths is actually not as hard as the other ones. So, all right, here's the next one. So you recently started an online business selling reusable coffee cups. Each month you have been selling 800 coffee cups at $15 per cup. Suppose that for every $1.50 increase in price per cup, 20 fewer cups are sold. Let X be the number of price increases. Okay, so we need to show that the revenue is this, right? Revenue is just like the money coming in. So whenever it's a bit hard to come up with the equation so, I like to, you know, test out a few values. So let's say there are no price increases, right? Because X represents the price increases. If there are no price increases, well, what's the revenue going to be? Well, it's going to be 800 cups times $15, right? Because that's what the cost per cup is. Now, what happens when we start introducing X equals 1? Well, I know that the revenue, according to this, for every $1.50 increase, 20 fewer cups are sold. So straight away I can make a connection here, okay? So I know that for every 1 increase, there's going to be 20 fewer cups sold. So that's going to be 800 minus 20 times by $1, well, I'll just say $15 plus 150, right? And so this is for X equals 1. Now X equals 2, well, what's this going to be? This will be 800 minus 2 times 20, right? Because now you've got, you know, 40 cups less times 15 plus 2 times 1.5. So now I'm starting to see the pattern. So here is where the price increase is happening, where this 2 is. Okay, so in general, when it's just X price increases, your revenue will be 800 minus 20X, representing each rise in price increases, times by 15 plus 1.5x, which is the price increase per cup. All right, so let's see if we expand this out, we get our revenue. Revenue is 800 times 15 is 12,000 plus 1.5 times 800, that's 1200x, minus 20 times 15 is 300x, minus 1.5 times 20 is 30x squared. So it looks like we're almost there. So revenue is 12,000 plus 900x minus 30x squared. And I think that's what they want. Yeah. Done. Okay, then finally, hence find the maximum revenue generated at the optimal price. So maximum revenue. So we've got to differentiate dr dx. And this should be pretty straightforward differentiation. So x goes, the constant goes, minus 60x. Solve for this is equal to 0. All right, and then, so x is equal to 900 over 60, which is 15. Okay, so that could be a max, but we just want to differentiate again to check that it definitely will be. So differentiating again, you're going to get minus 60. Now, obviously, minus 60 is always less than 0, so therefore you are going to get a max. So therefore, 15 will be the optimal number of price increases. So therefore, to find the maximum revenue, we just got to sub it in back to our equation here. So when R is equal to 15, it's 12,000 plus 900 times 15 minus 30 times 15 squared. So that's 18,750. All right, so let's look at this one here. So a regular canvas sheet is folded from the cover of tent with a pentagonal cross section as shown in the diagram. So they've got this shape here, folding it like so. The vertical heights of the side of the tent are y meters and the slant height's 4x. So you can see that there. Show that y is equal to 10 minus 4x, given the area of the sheet is here, 120. All right, so what's this? This is the area of the sheet, right? So if it goes 4x, that's 8x plus 2y. So I know that the area here is going to be 8x plus 2y. That's just all the way across, times 6 meters. So the area is 48x plus 12y. And I know that the total area is 120, right? So 120 is 48x plus 12y. Make y the subject, it looks like. So 12y is equal to 120 minus 48x. Divide through by 12, so that's 10 minus 4x. Done. Alright, so part B says show that the height is root 39x over 2. So in this shape here, well, just by looking at it, straight away, like whenever I see a right angle triangle, I'm thinking Pythag. So if it goes 5x all the way across, so that means this has to be 2.5x. 2.5x. So just choosing one of the triangles, I know that h squared plus 2.5x squared is equal to 4x all squared. Let's do some algebra here. So h squared is equal to 16x squared, and I'll move the 2.5x squared to the other side. 2.5 squared is 6.25, which is also 25 on 4. And then let's just simplify that. So 16 minus that is going to be 39 on 4 because they're like terms. So now I just square root both sides. So h squared, h is equal to root 39 x, and then root 4 is 2. So there we are done. All right, question C. Find the exact find the exact value of x which maximizes the volume of the tent. Okay, so the volume of the tent is going to be the shape, the cross-sectional shape, times by 6 meters, so the area times how far back it is. So what is the cross-section of the shape? So I can see it's made up of a triangle and a rectangle, so the top and the bottom. So the triangle, right, is going to be half base height. So half times 5x times the height we just found, which is 39 on 2x. So that's the area of this triangle. So let's just simplify that. So I guess, we've got x and x here, that's x squared. So 5x squared over, root 39 over 2 times 2 is 4. That's the triangle. And then the rectangle, right, is going to be 5xy. It's pretty straightforward. But we need to obviously probably sub out that y because we're trying to get everything in terms of x. And so using part A, we found that y is equal to 10 minus 4x. So I sub that in. So 50x minus 20x squared. So adding both of these together, okay, so let's just make this a bit prettier. So the total area is going to be 5x squared root 39 over 4 plus 50x minus 20x squared. All right, so here's my area equation, but I'm actually trying to maximize the volume. So what I need to do, right, is actually got to times this all by 6 to get the volume. So the volume is going to be 30x squared root 39 over 4 plus 300x minus 120x squared. And now I can differentiate dv over dx. So going ahead and differentiating with respect to x. So bring the 2 down, becomes 60x root 39 on 4 plus 300 minus 240x. Okay, now I need to solve this when that equals 0. So I'm basically just going to have that equal to 0. So let's see what we can do here. So I'm just going to times through by 4. So 60x root 39 plus 1200 minus 240 times 4 is 960 is equal to 0. Now, since I have x here and x here, I'm going to keep that on this side and move the 1200 to the other side. So 60x root 39 minus 960x is equal to minus 1200. Factorize the x out, so 60 root 39 minus 960 is equal to minus 1200. Divide through by that stuff in the brackets, which is 60 root 39 minus 960. So we can probably simplify the denominator, right? By we've got 60 and 960. So if I take out a 60, I should have root 39 minus 16. So 60 goes into 1200 20 times. So that should be minus 20 over root 39 minus 16. Okay, so that is my x value. Let's see if it is actually a maximum. So we probably have to differentiate one more time. Let's just see where it is. So here is our first derivative. So we do need to find the second derivative just to show that it's going to be a max. D squared v dx squared. So this will be 60 root 39 over 4. X disappears. The 300 disappears. Minus 240. Okay, so we have this situation here. If you just put this in the calculator, it should give you a negative number. So let me just confirm. All right, so 60 root 39 over 4 minus 240. And as you can see, this is less than 0. So therefore, since it's less than 0, it's going to be concave down. So therefore, this is going to be a max. So therefore, our answer of minus 20 over root 39 minus 16 is our max. All right, that's it for today. It's kind of a longish video, but I hope you saw a range of different optimization questions. If you have any questions or want to see anything else, let me know in the comments below. But thank you for watching. I'll see you in the next one. Peace.